The history of the steam locomotive is often viewed through a lens of deep nostalgia. We romanticize the golden age of rail, the rhythmic, percussive chuff of the exhaust, the lonely wail of a whistle echoing across a valley, and the sheer mechanical majesty of these iron horses conquering the wild landscape. To the observer, a steam train is a thing of beauty. But the reality for the men who actually operated these leviathans was often brutal, physically punishing, and inherently dangerous. For the first century of railway history, design conventions were governed by a strict, almost religious layout. You had the firebox and the cab at the rear, the massive boiler in the middle, and the smokestack at the front. This configuration wasn't a choice, it was a necessity of the era. A fireman needed to be positioned directly next to the tender, the car carrying the fuel, so they could physically shovel coal into the hungry firebox. However, this design came at a steep price. It prioritized the generation of power over the safety of the human beings controlling it. It left engineers sitting at the back of the machine, forced to peer through a literal forest of steel, steam, and billowing smoke just to see the track ahead. Nowhere was this design flaw more lethal than in the treacherous, snow-capped peaks of the American West. It was here, in the unforgiving geography of the Sierra Nevada mountains, that the Southern Pacific Railroad was forced to abandon tradition. They pioneered a radical, controversial, and ultimately tragic design known as the cab-forward locomotive. And this is the story of how an engineering marvel solved a fatal problem only to create a terrifying new one. Part 1. The Blind Engineer and the Suffocating Tunnel. To truly understand why the cab forward was necessary, we must first appreciate the severe limitations of the standard steam locomotive in the late 19th century. As the demands of commerce grew, locomotives had to grow with them. To haul heavier freight over longer distances, boilers became longer and wider. For the engineer sitting in the cab at the rear, the view ahead became increasingly obstructed. Imagine, if you will, driving a massive semi-truck, but instead of sitting in the front seat, you are driving from the back of the trailer, trying to see the road through the windshield of the cab 50 feet in front of you. On the open plains of the Midwest or the gentle rolling hills of the East Coast, this was a manageable nuisance. An engineer could simply lean out the side window to spot signals or obstructions. But in the hostile geography of the western United States, visibility was not just a matter of efficiency, it was a matter of survival. The Southern Pacific Railroad's route through the Sierra Nevada mountains, specifically the infamous Donner Pass, was an engineering nightmare. To keep the tracks open through winters that regularly dropped dozens of feet of snow, the railroad constructed miles of wooden snow sheds and blasted long tunnels through solid granite. Effectively, the trains were running inside a continuous enclosed tube of wood and stone for miles at a time. In these confined spaces, the standard locomotive design transformed from a vehicle into a death trap. As a conventional steam engine blasted uphill at full throttle, fighting gravity with maximum power, the exhaust stack at the front spewed a violent mixture of superheated steam, thick coal smoke, and deadly carbon monoxide directly into the roof of the tunnel. Because the train was moving forward, this toxic cloud would roll backward, instantly enveloping the cab where the crew was stationed. The conditions inside the tunnels were apocalyptic. Temperatures in the cab could spike to over 100 degrees Fahrenheit, nearly 38 degrees Celsius, in a matter of seconds. The air turned into a poisonous, caustic soup. The exhaust temperature near the stack could reach a searing 750 degrees. Reports from that era are harrowing. They describe crews wrapping wet towels around their faces and lying flat on the floorboards, gasping for the thin layer of oxygen near the ground. Engineers suffered from chronic respiratory issues, blinding headaches, nausea, and disorientation. In the worst-case scenarios, crews would lose consciousness due to asphyxiation while the train was still moving. This left a runaway locomotive careening through the mountains with a passed-out crew, a terrifying prospect for anyone on the rails. The route earned a grim reputation among the workforce. Many railroaders referred to the snow shed run as a death sentence and simply refused to work the line. The Southern Pacific faced a crisis. They had conquered the mountains with rails, but they could not operate them safely with men. or Part 2, A History of Failed Innovation. The concept of moving the cab to the front of the locomotive to improve visibility was not a new idea born in the Sierras. It had been attempted decades earlier, though for different reasons and with mixed results. In the 1860s, an engineer named Matthias Forny recognized the visibility problem plaguing urban railways. He patented a design that placed the cab at the front of a tank engine. This design was primarily intended for elevated urban railways, like those in New York City, where tight turns and frequent stops required excellent visibility and traction. The Forny design worked by placing the weight of the water tank over the driving wheels, increasing adhesion. Visual evidence from the Library of Congress shows these peculiar machines with the engineer perched at the very front, or with the boiler trailing behind. While successful in the niche environment of slow-speed, short-distance urban commuting, the design was flawed for mainline railroads. It simply did not scale. It lacked the fuel capacity for long hauls and became dangerously unstable at high speeds on rough terrain. Across the Atlantic, European engineers also flirted with the idea. Between 1900 and 1910, the Italian state railways tested mulette-style locomotives in the flat Po Valley. These engines placed the cab forward to give the driver a clear view of the signals. However, the flat terrain and open air meant that smoke accumulation was rarely a fatal issue. The engineers found that the psychological benefit of seeing the track better did not translate into measurable operational efficiency. The experiments were quietly discontinued. Meanwhile, in Germany, the focus was entirely on speed. The Deutsche Reichsbahn's Class 05, a streamlined beast capable of reaching 127 miles per hour, kept the cab firmly at the rear. German engineers argued that at such high speeds, the crew was safer behind the boiler, protected from the wind and potential collisions. By the 1930s, the consensus in Europe and most of America was clear. Front cab designs were a solution in search of a problem, but back in the Sierra Nevada, the problem was very real. Before a custom engineering solution could be found, Southern Pacific crews resorted to a desperate measure. They ran their standard locomotives in reverse. By running tender first, the cab and the crew entered the tunnel before the smokestack. The exhaust would trail behind them, leaving the air in the cab relatively clear. While this solved the immediate threat of suffocation, it was an operational disaster. The engineer was now staring at the flat, blank metal face of the tender. Visibility was reduced to near zero. They could not see signals, rock slides, or broken rails. Brakemen and conductors lost the ability to communicate effectively with the engineer using hand signals. Speed dropped, and the accident rate climbed. It was a classic pick-your-poison scenario: risk death by suffocation or risk death by derailment. Part 3. The Oil-Fired Revolution. The breakthrough that saved the Southern Pacific crews did not come from a change in locomotive architecture alone, but from a fundamental change in chemistry. In the early 20th century, the Southern Pacific began transitioning its fleet from coal to oil. California had abundant oil reserves, making it a cheaper fuel source. But critically, oil changed the physics of firing a locomotive. With coal, a human being had to physically transfer the solid fuel from the tender to the firebox, necessitating that the two be adjacent. With oil, the fuel could be pressurized and pumped through pipes. This was the eureka moment. If the fuel could be piped, the firemen didn't need to be next to the tender. The tender could remain at the rear of the train, and the fuel could be pumped the entire length of the locomotive to a firebox located at the front. In 1909, Southern Pacific commissioned the Baldwin Locomotive Works to build the first true cab-forward locomotives. These machines were behemoths. They were articulated locomotives, in meaning they had two sets of driving wheels that could pivot independently to handle the sharp mountain curves. But the most striking feature was the cab itself. It was a fully enclosed steel room, heavily riveted to the very front of the frame, sitting ahead of the boiler, the smokestack, and the driving wheels. The design was a revelation. First, there was the visibility. The engineer sat behind a large glass window with a panoramic view of the track. For the first time, they could see every rock on the rail and every signal light clearly. Second, and most importantly, was the air quality. The smokestack was now located behind the crew. As the train entered a tunnel, the deadly plume of exhaust was blasted rearward away from the cab. Third came crew comfort. The oil firing meant the fireman no longer had to break his back shoveling coal. He simply adjusted valves to control the flow of oil to the burners. The result was immediate and profound. The reports of fainting, nausea, and tunnel sickness vanished. Crews finished their shifts alert and healthy. The cab forward became the signature engine of the Southern Pacific, a symbol of man's ability to adapt machinery to nature's harshest demands. For decades, these giants roared through the snowsheds of the Sierras, seemingly invincible. Part 4. The hidden serpent in the design. But engineering is rarely a path to perfection, it is usually a trade-off. While the cab forward solved the problem of asphyxiation, it introduced a new, subtle, and terrifying vulnerability that lay dormant for years. The Achilles heel of the design was the fuel delivery system itself. Because the tender was at the rear and the firebox was at the front, the oil had to travel the entire length of the locomotive, often over 100 feet. These pressurized oil lines ran along the side of the boiler, passing directly alongside the massive churning driving wheels and the hot steam cylinders. A steam locomotive is a violent environment. It shakes, rattles, and vibrates with immense force. The piping system was subjected to constant mechanical pounding, thermal expansion and contraction, and the grinding vibration of the rails. Southern Pacific mechanical bulletins frequently warned maintenance crews to inspect these lines. A single worn gasket, a loose coupling, or a fatigue crack could spell disaster. In the open air, an oil leak was messy but manageable. The wind would disperse the fumes, but inside a tunnel, the very environment the locomotive was designed to conquer, a leak was catastrophic. If pressurized oil sprayed onto the white-hot metal of the boiler or the wheels, it would ignite instantly. In the confined bore of a tunnel, the fire would consume all available oxygen and turn the space into a blast furnace. Part 5. The Inferno at Tunnel 26. The theoretical risks of the cab-forward design became a horrifying reality on a cold November night in 1941. The incident occurred at Tunnel 26 in the Santa Susana Pass, a steep and challenging grade just north of Los Angeles. Southern Pacific Cab Forward number 4193 was powering a heavy freight train consisting of nearly 100 cars uphill. As the massive engine entered the darkness of Tunnel 26, the crew was confident. The design had protected them for years. However, unknown to them, a stress fracture or a loose joint in the oil feed line had developed. As the locomotive strained against the grade, the oil line ruptured. Gallons of pressurized crude oil sprayed out, coating the rails and the driving wheels. First came the loss of traction. The oil acted as a lubricant. The massive steel wheels lost their grip on the rails and began to spin wildly. Then came the stall. The train lost momentum and stopped deep inside the tunnel. Then the slip. Gravity took over. The heavy train began to slide backward. Finally, the brake. The violent forces caused a coupler to snap near the 75th car. This severed the emergency air brake line, triggering the brakes on the entire train instantly. The train jerked to a violent, shuddering halt. And then came the fire. The leaking oil, dripping onto the superheated rails, and the hot metal of the undercarriage, ignited. The cab-forward design, which had been created to keep smoke away from the crew, now worked against them. The fire started beneath and behind the cab. Because they were in a tunnel, the heat and smoke could not escape upward. Instead, the chimney effect of the tunnel drew the flames and toxic smoke forward, wrapping around the cab. The crew was trapped. They were at the front of the train, deep inside the mountain, with a wall of fire blocking their only exit back through the tunnel. The cab, once their sanctuary from exhaust, became an oven. The tragedy was absolute. 5 crew members died at their posts, unable to escape the inferno. The fire burned with such intensity that it raged for 3 days. It consumed the locomotive. The wooden lining of the tunnel and the tragic cargo, Over 300 head of cattle in stock cars behind the engine were also killed by the smoke and heat. The Tunnel 26 disaster was a grim wake-up call. It highlighted that the very innovation used to save lives, piping oil to the front, had created a vulnerability that could take them. The solution to suffocation had inadvertently created the risk of incineration. Conclusion: the legacy of imperfection. The era of the cab-forward locomotive eventually came to a close, not just because of the risks, but because of the arrival of the diesel-electric locomotive. Diesels brought with them pressurized, air-conditioned cabs that solved the tunnel suffocation problem without the need for complex piping or radical layout changes. By the late 1950s, the great cab-forwards were retired. Today, the only one, Southern Pacific No. 4294, survives as a museum piece in Sacramento, California. However, the story of the cab forward remains a vital case study in the history of engineering. It illustrates the complex dialectic of technological progress. A problem arises, a solution is engineered, and that solution often begets a new, unforeseen danger. The engineers of the Southern Pacific did not fail. They succeeded in conquering the Sierra Nevada when no standard machine could. They saved countless lungs and lives from the slow death of smoke inhalation. But the tragedy of Tunnel 26 serves as a somber reminder that in the battle between human ingenuity and the unforgiving laws of physics, nature often demands a price. The cab forward stands today as a monument to that struggle, a testament to the bravery of the crews who rode the front of the iron horse, staring directly into the dark, for better or for worse.